Welcome to the CompTIA A+ 220 1101 or Core 1 exam. This is Objective 2.8, Network Tools. When you're running new cables, it is very common to run the cable itself without any connectors on the end. So you need a tool that's specifically designed to add those connectors on the end of the cable. We call these cable crimpers. And they look very similar to a pair of pliers, but they're actually very specially designed to add that connector onto the end of the cable. There are different types of crimpers that you should use, and they're designed to add a connector onto the end of coaxial cables, twisted pair cables, or fiber. This is usually the final step in the process. You've already run the cable through the floor or the ceiling or the conduit or wherever it is, and you have a cable on both sides that need to have a connector like this. For twisted pair cables, these crimpers are pushing prongs through the installation and through the copper in the wire itself. This is what a RJ45 connector would look like when it's finished. You can see the connector sitting just above the RJ45 right here, and when you use the crimper, it pushes down all of those connectors like you see in the picture. When the wires are connecting, you can see the sharp prongs at the bottom are pushed through the insulation to make a good connection with copper of each individual strand. This extends the copper inside the wire to the copper connections, which then connect to the device that you're plugging into. After making the crimp, you can see that those connectors have been pushed down into the RJ45 connector, and you can see where those spiky ends at the copper have now made a connection down to the RJ45 connector. If you're running your own cable, then you'll need a crimper to be able to add the connector at the end of the cable. You might want to get a good pair of electrician scissors. These are sometimes referred to as cable snips, and it's nice to have these strippers available so you can remove the ends quickly. There are different types of wires, so if you're using category 5 versus category 6 or cat 7, then you'll need different connectors at the end of each cable type. If you're working with the wireless network, then you don't have to spend a lot of time crimping cables. But you do have to spend a lot of time understanding the different frequencies that are in use on the wireless network. To be able to understand exactly what's happening over the air, you might want to make use of a Wi-Fi analyzer. These are analyzers that listen to all the signals on the wireless network, and they're able to provide you with information about what frequencies are open and in use. The Wi-Fi analyzer might be software that you would add to a laptop or a mobile device, or might be a purpose-built piece of hardware that's designed to analyze Wi-Fi networks. This can be very useful if you're in an area with a lot of Wi-Fi access points and will allow you to see exactly where the interface might be occurring on the network. And you can visually see a graph just like we do here with all the different laps, and you can make an intelligent decision of how to manage your wireless network. If you ever worked in a data center or a large network where there are hundreds or different types of cables, then it's ideal to have a tester. Sometimes you want to hear the sound of a tone, so you could use a tone probe. Both of the components that you would use to identify the cable, for example, a tone generator would add signal to the copper wire, and the probe, is inductive. This inductive probe doesn't need to touch the copper that's inside of the cable. It just needs to get close to the cable, and then you can hear a tone being generated, so you know that the cable is live and in use. This allows you to easily find where a cable might be, especially in an environment where hundreds or thousands of cables are being run across a data center. You would first connect the tone generator to one end of the wire. This could be done with a modular jack that's on the tone generator, or you might have alligator clips to put on a connection type of cable, you would then go to the other end where this cable is, and then in a large bunch of cables, you would use this inductive probe to move from cable to cable and identify exactly which cable contains that particular tone. In some environments, you're not connecting to an RJ45 connector. You're instead connecting to a punch-down block. This is a punch-down block, and you can see that it's a specialized tool that you can use to connect and punch-down block permanently. This can be pretty tedious if you're working with a lot of cables, because you're taking each wire that's inside the cable and punching it down into its own slot. And you have to use the tool individually to fasten those wires to punch it down to the block. When you're using this punch down tool, it's not only punching down the wire, but it's cutting off any excess wire and making a next connection to the block. When you're working with the punch down block, you're usually managing many different cables, so it's important to have very good organization. Another great tool to have in your tool bag is a cable tester. These usually come in two different units. You can plug each of them into two different ends of the cable, then they'll perform a continuity test and tell you if pin 1 is connected to pin 1 or pin 2 is connected to pin 2, and so on and so forth. Some cable testers can also tell you if you happen to miss any of these cables or not punch them down properly, so you may be able to tell if you crossed wires between different pins. These cable testers are relatively simplistic. They don't have a lot of advanced functionality. For example, a cable tester might not be able to tell you what the crosstalk values might be between the wires or how much the signal loss is. When you're troubleshooting, it's useful to know if problems you're seeing are related to the cable or related to the interface of the device. One way that you could test that is through the use of a loop-back plug. You would have data coming out of an interface, looping back around, and that's going right back into the same device. This allows you to send information out of the serial port, receive that information immediately back in the serial port, and be able to compare those two values to see if they match. If they don't match, then it's very possible there's a problem with that physical interface. That's a very good way to test. There are also loopback cables you can use for Ethernet, T1, even fiber connections. These are not crossover cables. You can see that you're connecting multiple devices together. This is instead used to send out data on the interface and come right back to the same interface. Crossover cables are a bit different. They connect two devices directly to each other, but a loopback is simply connecting to itself. When you're troubleshooting a network, it's sometimes useful to see the data that's going over the wire itself, but having access to that data could be problematic. One way you could see the data on the connection is with the physical network tap. This allows you to disconnect a link, put our physical tap in the middle, and take a copy of all that data and send it to an analyzer. This might be a passive tap that doesn't require fiber. We commonly see with fiber taps. Or it might be an active tap. This is able to tap copper connections but require power to be able to do that. If you don't have a physical tap, you may be able to use a tapping function that's built into your switch. This is called a port mirror or a span. A span is an abbreviation for switched port analyzer. This function is built into the switch and able to take data between different interfaces and copy it to a third interface that you can then connect and analyze. There are obviously resource limitations in the switch and bandwidth limitations on the interface, but if you need something very simple, it can be used temporarily. Looking closer at this physical tap in this picture, you can see how the tap operates based on design that's on the outside. Physically, you can see that you would break the connection between these two devices, but if you put in the middle another cable between these two devices going over direction, we can break that connection and put the tap between them as well. Okay, You're at the end of Objective 2.8. Here's a pop quiz. Which network tool can sniff packets at the hardware level? Cable tester, span, loopback plug, or a crimper? And it would be a switch port analyzer. We were just looking at that. You can do that from a switch itself. If it's a managed switch, it's intelligent enough. Or you can use physical hardware to do the sniffing. Thanks for watching.